Have you ever noticed the tire under your feet? That seemingly simple, round, black thing is actually one of the most sophisticated engineering inventions in the modern mechanical world. Every time you turn the steering wheel, step on the gas, or brake suddenly, the tire is the only thing in direct contact with the road, carrying the entire weight of the car, absorbing all the shocks, and responding to every command of the driver in a split second. But how is it made? It's not just rubber. It's not just a mold. The tire is the result of hundreds of steps, from sap from trees in the rainforest to steel forged in industrial furnaces, from thin fabric to electronic sensors, RFID chips, and laser shaping machines. On today's journey, we'll explore the tire from the inside out, layer by layer, cut by cut, heat pressed by heat, to understand why something so seemingly ordinary plays such an extraordinary role in every trip. Buckle up, and let's get started. When we look at a tire from the outside, we only see a black round block with grooves and patterns. But in fact, inside it is a multi-layered architecture. Each layer has a separate, indispensable function. The first layer is the inner liner, a super airtight synthetic rubber that prevents air from escaping and keeps tire pressure stable. Next is a woven fabric layer, usually made of polyester, nylon, or rayon, that is rolled thin, attached to the rubber to form the main frame layer. These fibers are woven at a precise angle, helping to increase durability while maintaining flexibility. On the outside are steel rings, beads, steel fibers twisted into rings, covering the rubber layer to tightly connect the tire to the rim. The pressure from the steel rings is what helps the tire not to fly off when the car turns sharply or runs at high speed. On top is the tread layer, the place that directly contacts the road surface. This is where material science, aerodynamics, and even design art converge. The tiny grooves, called sipes, aren't just for show. They help improve grip, especially on slippery surfaces in rain or snow. A high-performance tire can have as many as 1,500 of them, designed using software that simulates shear and water flow. Now that all the layers have been prepared, cut and processed precisely, the tire assembly process begins. And unlike piecing together a sandwich, this is one of the most computationally demanding and automated steps in the entire chain. The building drum is the heart of the process. It is a rotating shaft controlled by a pneumatic and electric motor, where each layer of material is placed in the correct order. First comes the inner liner, laid flat as a base layer. Then, each layer of pre-woven reinforcement fabric is placed so that the fibers are oriented precisely, usually at 90 degrees to the direction of the wheel's movement. The steel belts are then placed on top. These are the layers that keep the tire from deforming when the vehicle is traveling at high speeds or when turning sharply. Once the casing is complete, the steel beads are attached at both ends, and the tread is rolled around the outside, enclosing the inner structure. Everything has to fit perfectly, not even 1 millimeter off. In modern factories like Michelin's, this process is monitored by load cells, high-speed cameras, and even lasers. Some tires even have RFID chips integrated into them at this stage, allowing for tracking of production history, testing, and even performance later on. When all the components are attached, you have what's called a green tire. It looks like a tire, but it's still soft, unpatterned, and not ready to roll. But the journey doesn't stop there. Now it's time to bake the tire, literally. After assembly, the raw tire, also known as the green tire, is not yet ready to roll. To achieve its final strength, elasticity, and shape, the tire needs to undergo a vulcanization process. Vulcanization is the process of using heat and pressure to cross-link the rubber molecules, transforming the rubber from a flexible state to a strong, elastic state. During this process, the tire is placed in a steel mold with the desired shape and pattern. An air bladder inside the tire is inflated with superheated steam, forcing the tire into the mold at high pressure. This heat and pressure triggers a chemical reaction between the rubber and sulfur, creating a strong network structure for the tire. The vulcanization time is strictly controlled to ensure that the tire achieves the required physical properties such as strength, heat resistance, and shape. Once complete, the tire is cooled and removed from the mold, ready for quality control. Before leaving the factory, each tire must undergo a series of rigorous tests to ensure quality and safety. Visual inspection. Employees inspect the tire surface for defects such as cracks, blisters, or foreign objects. Balance test. Tires are placed on a machine to check for evenness and balance, ensuring that the tire does not cause vibration when the vehicle is operating. Durability test. A number of tires are randomly selected to test for durability, load capacity, and performance under different conditions. X-ray inspection. X-rays are used to detect defects inside the tire that are not visible to the naked eye. Only tires that pass all these tests are packaged and shipped, ensuring that consumers receive a safe and high-quality product. When tires reach the end of their useful life, they are not simply thrown away, but can be recycled for other purposes, contributing to environmental protection. Crushing. Old tires are crushed into small pieces for use as construction materials, such as paving, playgrounds, or as alternative fuel. Recycling into new products. Rubber from old tires can be used to produce products such as rubber mats, shoe soles, or other items. Pyrolysis. Some advanced technologies use the pyrolysis process to decompose tires into oil, gas, and coal, serving other industries. Recycling tires not only helps reduce waste, but also saves resources and energy, moving towards a sustainable circular economy. From the sap of the rubber tree to the finished product, the journey of a tire is a testament to the combination of science, technology, and human dedication. Every step in the manufacturing process plays a vital role, ensuring that the tire not only meets technical standards, but also contributes to the safety and efficiency of every ride.